Hi, I'm going to talk about this JD William case. This company has $10 million to invest on 5 bonds. The bonds are available at different times and mature for different amount of time. For example, bond 1 has a maturity of 3 years, is available at the beginning of 2019. It has an interest rate of 3.5 annually, which means that over these 3 years, the total cumulated return will be 10.87%. So that means if you invest $100 at the beginning of 2019 to bond 1, you will get the principal back plus interest of $10.87 at the end of 2021. And once you invest that $100 into bond 1, you cannot touch it throughout these 3 years from 2019 to 2021. So how do we model this problem? Well, here's a decision variable. We have 5 bonds, but actually there's another option, which is not to invest at all. And so basically the other option is to keep in cash. Let's call holding cash a bond as well. It's a bond 0 with 0 interest. So here's a way to choose your decision variables. The decision variables will be the amount you're going to invest in each bond. And I have a table here to visualize it. So X1 through X4 is the amount you're going to invest in bond 0, which is cash. And the maturity of cash is 1 year, okay? Because we assume that you invest at the beginning of each year only. So you can see cash as a bond with 1 year maturity and in 0 interest rate. X5 is the amount to invest in bond 1. X6 is the amount to invest in bond 2. X7, the amount to invest in bond 3. X8 for bond 4. X9 for bond 5. So these are the amount to invest in those bonds at the beginning of the corresponding years. So now, how do we set up the constraints? And this is the key part. So the constraints basically keeps the balance of cash flow. Basically, each constraint says that the amount available to invest at the beginning of a year should equal to the amount that is actually invested in every year. For example, 2019, the amount that is invested in that year is simply, looking at this table, there are 3 instruments, 3 bonds you can invest: cash, bond 1, and bond 2. So the total investment is simply the sum of them. X1 is the amount you invest on bond 0, plus X5 you invest on bond 2, plus X6, the amount you invest in bond 2. And this amount should equal to the available amount for investment at the beginning of 2019, which is 10 million. So that's a balance for 2019. Now we move on to next year, 2020. So what is the total investment in that year using those decision variables? Well, you can invest in bond 0 and bond 3 and also bond 5. So bond 0 is X2 plus bond 3, which is X7, plus bond 5, which is X9. And the amount you need source of funding, so it needs to equal to whatever you're available at the beginning of 2020. So what are the sources of funds at the beginning of 2020? Well, Then let's see what are the bonds that are mature at that time. Exactly what are the bonds that are mature at the end of 2019. In this case, we have cash, which is X1. X1, the amount X1 will be available for invest at the beginning of 2020. So X1. Is there any other else? Well, no. Bond 1, if you have any investment in it, it won't be available at 2020. Bond 2 as well. Bond 3, 4, 5 haven't happened yet. Okay, so that's it. Move on to 2021. So what are the investments that takes place in that year? Well, first one, X3, the cash. Not bond 1, not bond 2, not bond 3, bond 4, yes, okay. Bond 4 bond 4 opens at that year's, and that amount need to be equal to the total supply of funds, available funds. Okay, the funds that will become available at the beginning of 2021 are the ones that are mature at the end of 2020. So that includes the cash X2 plus bond 1 not mature yet. Bond 2, yes, it matures at the end of 2020. So how much can we get out of it? Well, the total return is 6.09%. So that means we will get 1 plus 1 plus 0.069 times x6. That's an amount we will get out of bond 2 at the end of 2020. Okay, bond 3, 4, 5, well, they are not mature or not open yet. Okay, so that's it. That's a total source of funding in 2021. Move on to 2022. The total investment in that year is first cash, and that's it. Okay, so the source of fundings, the bonds that are mature at the end of the previous year, 2021, would be cash X3 plus, okay, bond 1 is mature at that time, interest rate 10.87, so the total return will be 1.1087 times the investment on bond 1, which is X5. Bond 2, no. Bond 7, yes, it will mature at that time with the interest rate 10.25%, so you get 1.1025 times X7. Bond 4 and 5, no. Okay, so these are the so-called balancing constraints. It makes sure that the flow of money makes sense. Supply of money equals to total investment of money. And our goal is what? Our goal is to maximize the total cash in the end of 2022. Okay, so how much money would we have by the end of 2022? Well, at that point we'll have the cash X4, and also we will have bond 4 and 5 mature. So their corresponding return plus principal will be 1.1236 times X8 for bond 4 plus this for bond 5. So that is our objective to maximize. But however, don't forget, the case also says that, well, there's a limit on bond 2. The case says that you cannot invest more than 40% of the 10 million on bond 2. So how do we translate that into a constraint? Okay, so the amount we invest in bound 2 is x6. So essentially it says that the amount you spend on bound 2, which is x6, need to be less or equal to 40%, which is 0.4, of the total available funds, which is 10 million. Now I'm going to present this model formally. Here's a formal presentation. Okay, first I have a maximization of an objective, which is cash in end of 2022. And then I have all the constraints over here, 4 balancing constraint and 1 constraint for bound 2. But you see that it's a little bit messy. For the ease of building model later in Excel for solver, we need to move all the decision variables to the left-hand side of the equality or inequality. After doing so, it looks like this. For example, in the second constraint, x1 is on the right-hand side, so let's move it to the left-hand side. Here, you move it to the left-hand side, so you put a negative sign, okay? So you see, all the decision variables are on the left-hand side. Next one, the third constraint, x2 and x6 are on the right-hand side, so let's move it to the left. So it becomes this. So x2 and x6 come to the left-hand side, but you need to put a negative sign. Okay, so on and so forth. And now in this way, we have a formulation that is pretty neat. We have every decision variable on the left, constants or numbers on the right-hand side. With that, we can build a model. Okay, so here's the model we try to build. So in Excel, we have 2 parts. The upper part is for decision variables in objective value. The bottom part is for the constraints. First, we have 9 decision variables. These cells I highlighted in yellow will store their value. You can put any value over here, even empty, doesn't matter. This one is a coefficient of those variables in the objective function. So our objective function only involves x4, x8, and x9. So that's why you only see numbers for x4, x8, and x9. Those numbers are simply the numbers over here. You can leave the rest empty. For objective value, we use sum product. You give it 2 arrays. The first array here and the second array here. What sum product will do is it will do this cell times this cell plus this cell times this cell, so on and so forth, which in the end will give us this equation. Now let's enter the constraints. So 4 balancing constraint and 1 constraint on bound 2. So here we're going to simply enter again the coefficients for those decision variables in each constraint. For example, constraint 1 has only x1, x5, and x6, and the coefficients are all 1s. So we enter 1 for x1, enter 1 for x5, enter 1 for x6. And we can leave the rest empty. Excel will treat them as 0. And the left-hand side value is simply sum product. Okay, so of this array and this array. So again, it will do this times this plus this times this, so on and so forth, which eventually will store the value of x1 plus x5 plus x6 over here, depending on what x1 through x9 we give. So right now it's 0. And what we need is, we want this left-hand side value in the end to equal to 10. So we key in 10 here. Or I actually create a cell over here to store the amount of initial funds, 10 million. For second constraint, it involves x1, 2, 7, 9. Okay, so x2, start from x1, the coefficient is -1, x2 coefficient is 1, x7 coefficient is 1, x9 coefficient is 1. And we are going to use sum product again, but now we can simply copy the formula here. Okay, if you drag it down, if you go here and drag it down, you'll find that it's wrong. I mean, the problem is that now the reference to the value for decision variables become here, the blue one, which is wrong. Look, the location is wrong, so we need to drag it back. Or alternatively, a smarter way is to put the dollar sign over here for the blue cells, L8 to T8. If you're using a PC, then you can do it like me. Just click on anywhere in L8, press F4 once. Okay. Click anywhere in T8, press F4 once. You see there are dollar signs in front of L and 8, T and 8. That will fix a reference to T and whatever T and 8. Okay. We can actually drag it down all the way. You'll find that the reference is correct now. Okay, we can enter equation constraint 3. So we have -1 for x2, 1 for x3. For x6, we have -1.0609 and 1 for x8. For 2022, we have -1 for x3, 1 for x4, -1.1087 for x5, -1.1025 for x7, and the sign is equal to, in this case, and right hand side are 0, 0, and 0. For bound to limit, we have x6, which is 1, but less or equal to 4. Now we're ready to call solver. Okay, let me reset all. Okay, let's have a fresh start. So the objective is a goal. The goal is to maximize this. So you click on this cell and make sure you check the max box. So Excel knows that you're trying to maximize the number over here by changing variable cells. So these are your decision variables. So just select all of this, subject to constraints. You add constraints. Okay, these 4 constraints have the same sign, so we can select all of them equal to the right hand side. Just select all of the right hand side. Okay, click on add. They will add into the constraint. And now we can add another one, the last one, where this number need to be less or equal to the right hand side, this number, and OK. So you see both constraints are entered properly. And make sure you check this box, so that by checking this box, it will make sure that the decision variables are non-negative. So basically, in other words, checking this box takes care of this constraint. So we have everything expressed in linear terms of those decision variables. So in this case, we can use simplex LP. Click on solve. Here's the optimal solution. Here we have the optimal solution. Let's see what it looks like. So what it says is this. You're going to invest 4 million here in bound 2, and then using all of the funds when it becomes mature to invest in X8, which is bound 4, and then you still have 6 million which you will invest in X9. So you carry 6 million in cash in 2019, wait for a year and invest all of them to bound 5. So you probably notice one problem. This way of formulation make it very hard to see the final outcome. Very hard to visually see what it means. So I'm going to show you another way to model the same problem, but in a much easier way to visualize. Okay, here's it. So I have a table, 6 bounds, year, still the same returns. Some cells are in yellow, some are in blue. The yellow cells are the decision variables. So same, these cells represent the amount to invest in those bounds in those years. The blue cells just tell me that that's the time, that's the year the corresponding bound will be mature. And I have the balancing constraint over here. For every year, I store the amount of available fund here, and I store the total investment in that year over here. In the end, they should be equal to each other. For example, 2019, I start with 10 million, I just know it. Total investment in this year is simply the cash plus bound 1 plus bound 2. 2020, the available funds, well, there's only one source, which is the cash from previous year. Total investment, cash plus bound 3 plus bound 5. 2021, available funds are the cash from previous year and bound 2 that becomes mature. So I have the red cell times 1 plus this interest. So the principal plus interest for bound 2. Investments, cash plus bound 4. 2022, source of funding, cash from 2021 plus the matured bound 1 and the matured bound 3. Okay. I can only invest on cash in 2022. My cash at the end of 2022 is simply the cash in that year plus the matured bound 4 plus 5, of course, plus their principal and interest. Still have a bound 2 limit. The investment in bound 2 need to be less than 40% of total of the 10 million, so 4 million over here. Solver, try to maximize the cell by changing. Here you just simply select. If you're using PC, you can press down Control and select those yellow cells. Constraints, you just select this equal to this. Add, there's another one, bound 2 need to be less than 4 over here. Okay, check this box, simplest LP, now solve it, same result. But now you can easily to see what is the outcoming investment strategy.